All right, one more video, but the good news is we're not going to learn any new rules in this video. In fact, we're not really going to learn anything new at all. We're just going to apply knowledge that hopefully you had coming into this class with some things we've learned in this section to do a couple of examples and then call things good. This is me going through your homework assignment and looking for any problems that you might struggle with and trying to preemptively give you examples solving those problems. So suppose you have this function f of x equals x squared minus 4x plus 1, which for your convenience I've graphed in front of you. What if you want to find the equation of the tangent line to this function at x equals 3? It's easy enough to draw the tangent line itself. It looks more or less like this. And what we've been focusing on so far is finding the slope of the tangent line. But here, not only do we want the slope of the tangent line, we also want the equation of the tangent line. So this is going to be a multiple step question. Step 1, we'll want to find the derivative of this function f prime of x. Because remember, the derivative tells us the slope of the tangent line to a curve. And if we're going to figure out the equation of the tangent line, we better know the slope of the tangent line. So we'll first find f prime of x. Good news, when your function f of x is a polynomial like it is here, it's pretty easy to find the derivative. In the last section, the derivative of x squared minus 4x plus 1 was like a crowning achievement of the entire section. In this section, it's like, look at this and immediately tell it the answer is 2x minus 4. Cool. I now have an equation, 2x minus 4, which tells me the slope of the tangent line to this curve in red at any value x. But that's more than I need. I don't need the slope of the tangent line at any value x. I need the slope of the tangent line at this specific value when x is equal to 3. So now what I want to do is find f prime of 3. But good news, if you've already found f prime of x, f prime of 3 is super easy. Here's a formula that tells you the slope of the tangent line for any x. If you want to know the slope of the tangent line when x equals 3, copy what you see here, changing all the x's into 3's. You get 2 times 3 minus 4. You get 6 minus 4, you get 2. The slope of this line is 2. Oh yeah, kind of looks like you go up 2 units each time you go to the right 1 unit. F prime of 3 is equal to 2, or in the language of pre-calculus, m is equal to 2. When we talk about the equation of the tangent line, you're probably thinking y equals mx plus b. We now know m, we just need to figure out b. What b represents is the y-intercept. I can kind of ballpark it on this graph. What's it equal to? I don't know. You could probably even calculate it. You could probably figure out what this value is and feel pretty certain about your answer. But what if you were in a case where the numbers didn't work out so nicely and you had to figure out the y-intercept? Maybe you should figure this out algebraically and not rely upon the graph. One way you can do that is using what's called point slope form. I think we've already seen that in this class. We do y minus y1 is equal to m times x minus x1, and then we plug in for x1, y1, and m. x1 and y1 is any point on this line. Note that the point 3, negative 2 is given to us, but if that weren't given to us, we have x equals 3 right here, and we could figure out the corresponding y value by just evaluating the function at 3. Not evaluating the derivative at 3, but evaluating the function at 3. F of 3 would be 3 squared minus 4 times 3 plus 1. 9 minus 12 plus 1, that sounds like negative 2. If we didn't already know that this y value was negative 2, we could figure it out this way. I got y minus negative 2, in other words y plus 2, is equal to m, which is also 2, times x minus x1, x minus 3. I now have an equation of the tangent line, although typically when you're told the equation of the tangent line, implied is that you want it on slope-intercept form. So typically people go a couple steps further and say y plus 2 is 2x minus 6, and therefore y is equal to 2x minus 8. The equation of the line in green is y equals 2x minus 8. I believe we've done this before. I think this exact same question with these exact same numbers. But when we did it before, we didn't have these derivative rules, so we spent most of our time figuring out this slope. Now that we have derivative rules, figuring out the slope is fairly straightforward. That's the point that I wanted to make with this example. Unrelated to this example, one more question. It's often useful to know, and we'll see why it's often useful later in our class when we get into applications, when a graph is flat. Flat's in quotation marks because really what I should say is when the slope of the tangent line to a graph is horizontal. What we'll see in about a month is that locating points like this, where the slope of the tangent line to the graph is horizontal, is super important. To give you an idea of how important it is, we're going to end up calling those things critical points. Just based on the name, you can tell it's important. Can you figure out algebraically when a graph is flat? Absolutely you can, because all you have to do is figure out when the derivative equals 0. You solve the equation g prime of x equals 0. And since figuring out derivatives is something that we're pretty good at now, we can do that relatively quickly. If g of x is this function, maybe for you it's a one-step process to figure out that the derivative is 3/4 x squared minus 1. It might not be a one-step process for you quite yet. You might want to show several lines in between here and here. So hold yourself accountable. If you're not positive that this equals this, work that out on your own and convince yourself that the derivative of this is equal to this. But that's not our final answer because we're not just trying to find the derivative, we're trying to figure out when the derivative equals 0. So we take that derivative, 3/4 x squared minus 1, we set it equal to 0 and we solve. To solve this equation, you want to isolate the x squared. So let's add 1 to both sides and get 3/4 x squared equals 1. And then let's multiply both sides of the equation by 4/3. That gives me x squared equals 4/3. Now that I've isolated the x squared, I can take the square root of both sides of an equation. Be careful here. Students always forget that when you decide to take the square root of both sides of an equation, you got to put in a plus or minus. That's not to say all square root signs mean plus or minus. It's when you decide that you want to algebraically take the square root of both sides of an equation, you got to put in that plus or minus. The reason is there's a negative number that makes this equation true because a negative times a negative is positive. But there's also a positive number that makes this true because a positive times a positive is a positive. So I need this plus or minus to signify the two answers. You could probably leave your answer like this, although if you were really good in a trig class, you might have learned that you can rewrite this as the square root of 4 over the square root of 3. And you might know that the square root of 4 is just equal to 2. So I could say that this is 2 divided by the square root of 3. And you might have even learned that generally speaking, it's not a good idea to leave square roots in the denominator. So we do this process called rationalizing the denominator, where we multiply the top and the bottom of the fraction by the square root of 3, and we get 2 times the square root of 3 over 3. I'd argue that the best possible answer for this question is there's two solutions. One at 2 times the square root of 3 divided by 3, and one at the negative of 2 times the square root of 3 over 3. Although if I'm being perfectly honest, unless I specified that you need to rationalize the denominator, I would say that this answer right here should be marked 100% correct. That's the last of my videos for this section. You're probably ready to be done with this section. If you've made it this far, I'm really proud of you. The last thing you probably want to do is watch another video. However, I'm going to ask you to watch one more video, and I think you'll be glad if you do. It's time for another one of these 3 blue, 1 brown videos that I find absolutely brilliant and beautiful as you go through and watch them. This third video in this Essence of Calculus playlist talks about everything that we've learned so far in this section. And it proves a lot of the facts that I've shown you in different ways than I've shown you, which is kind of cool. And no, you don't need to know several reasons why something is true. But I find that if you can understand why something is true, instead of just memorizing why it's true, it's much more likely to stick with you. And watching this video, which is way better than anything that I could ever produce, might help you understand some of that stuff. I'd argue that you should watch this. Don't take any notes. Don't feel like you have to learn anything. Don't think you'd ever be tested on it. And just appreciate it for what it is. If you get anything out of it, great. It's only 17 minutes long, and it's pretty neat. The only comment that I want to make is when you go through and you're watching this video and you see references to dt, that's our h in the difference quotient. That's all I got for this section.